Greetings and salutations. My name's Andrew, and I'd like to talk with you all about some ideas our lab has been coming up with relating to developing clinical socio-technical systems for AI in healthcare. So the goals of this talk are fourfold. Without further ado, I'd like to divide it into three parts. The first is Winter is Coming, which discusses the existential threat to research and patient care posed by AI. The second part of Dragons and Valarian Steel discusses strategies, process, and tools that we can use to unlock the capabilities of healthcare AI. And the last part, The Prince That Is Promised, discusses upskilling of the current workforce and developing a new physician phenotype for the future. So, you may have heard of the hype cycle within technology. However, the AI hype cycle is special relative to other hype cycles. Similarly, this particular AI winter is special relative to other AI winters. So let's begin with the hype cycle. As you can see here, there are variations between adoption and disillusionment for any sort of new technology. There's generally a game-changing new technology that has a particular trigger, then everything gets super exciting, that's the peak of inflation, and then we find out, oh, it doesn't work as well as we thought it would, and that leads to the trough of disillusionment. Eventually this plateaus out, but you need to be able to ride both the highs and the lows. So there are some signs present that we're coming upon a AI winter or a trough in the hype cycle. However, this AI hype cycle is particularly special in the context of healthcare. We've had other hype cycles around other nascent technologies, such as electronic health records, minimally invasive interventions with robotic surgery or in vascular endovascular therapies, wearables, remote monitoring, but AI is different. So I'd like to turn your attention to our figure here that looks at several different domains for each technology. So first is whether or not the hospital requires consent to use it. The second is whether or not the patient requires consent, followed by whether or not it requires special end user training to use the technology, whether the technology is useful only at the group level or could be useful to individuals, whether or not the technology is actually effective on the per instance basis or only over time, and whether or not there's government regulation involved. So by way of example, with the electronic health record, you can see that clearly it requires a hospital consent to the system. A patient who has a personalized EHR that the hospital has adopted isn't particularly useful. Similarly, you can see that there's special end user requirements which require special training. It's really only useful over time, and obviously there's government regulation. Contrasting that with the adoption of robotic or other minimally invasive technologies, this is yes across the board. As you can see, the adoption of AI and ML technology is essentially no all the way across the board, which means that it's able to rapidly iterate and not necessarily constrained by many of the safety checks that have been incumbent to other technologies which we've had to struggle with in clinical medicine. So just to expand on the Game of Thrones mythology, so which house is surgery? I'm sure everybody's wondering. Clearly medicine is the North. And I would argue that surgery is House Stark. So why is medicine the North? First, for the longest period of time, we essentially functioned as a guild, a semi-separate and independent kingdom. But then, in say probably the last 70 years, we've more or less bent the knee to big business. This came in the form of pharma, medical devices, electronic health records, hospital ownership by non-doctors, HMOs and other managed care organizations, and now even potentially private equity. But to be fair, a lot of other industries and former guilds had similar lack of independence. So, in our second part, we're going to discuss some of the strategies, processes, and tools that you need to unlock AI capabilities and how that's going to help us survive, or dare I say even thrive, in the upcoming AI winter. So, I would say there are 4 strategies you want to focus on first. The first is adopting an agile mindset. For many questions, we need to just accept that humans can't do it alone, and certainly not at scale. There's a lot of internal and external factors that are contributing to the decrease in time that patients and physicians are able to spend with each other. So we need to learn how to work cautiously with AI-enhanced technologies to allow us to buy out time from other areas to spend more time with the human aspect of the doctor-patient relationship. Second, we should learn to think in systems and develop new frameworks for studies and evaluations. Thirdly, we should focus on accuracy with the development of any new AI technology, specifically around context-specific performance for a clinically relevant task using real-world data. So this is kind of the analogous to the difference between effectiveness and efficacy. And then finally, as we are able to prove accuracy, we should work on scale through minimizing technical debt and optimization of the various different capitals that we as physician leaders have at our disposal. So let's talk about what domains matter in the real world. So our lab, the Alchemy Lab, has come up with 2 domains that represent minimal viability for clinical deep learning models. The first is accuracy, and the second is alignment. Essentially, accuracy is using real-world data. How do these models perform in terms of getting the right answer? So depending on whether or not the model is deterministic or generative, you have different considerations, which I can go into more. However, it's very important to focus on the input data considerations. What is the observability of this data? What is the transparency of the labeling ontology that we use? And then what is the provenance of the labeling process? So did we get the nearest med student to label whatever they wanted? Did we have board certified physicians do it? Were they board certified in this specialty? How many were there? What happened if there were edge cases? How did we break ties? That aspect of building accuracy and trust and robustness in our methods is super, super important. The second area is around alignment, which essentially asks, assuming every factoid in this output is correct, is it in the format that we need to have at the point of care? Is it going to be something that I'm going to actually adopt and use this system, or is it going to spit out great expectations, the progress note, and I'm basically no better off than if I did it by hand? We've also developed a trustworthiness framework by which to evaluate how a system performs to enhance its stickiness in terms of adoption. One of the challenges is that traditional prior research efforts have been kind of myopically focused on the idea of mechanistic interpretability. Think of it as, do we have a math proof that this output is correct vis-a-vis these inputs? However, in the context of a socio-technical system, there are many other elements that are super important for actual expert human clinicians to trust a system enough, or to have the system be trustworthy for them to potentially trust the system, that would lead to better adoption. So I can go into more detail on each of these. Let's run this Jeopardy style. So you guys call out what you want, and I will go into more detail about each one of these. Finally, one of the areas that is super important for developing a sustainable pathway for impact is recruiting the right type of talent into the pool. So as a challenge to the status quo, I would say that, if you go to any med school in America and ask people to raise their hands for majors, it's basically 90% biology, chemistry, and biochemistry majors, which there's nothing inherently wrong with. However, the challenge is that we do not have a critical mass of people who are technical enough to develop these types of systems for the future. There's an imbalance between our current workforce, or the new incoming workforce, and the task at hand. The problem with that is it's going to lead to other people making these determinations for us. So if we don't have the capability to develop these types of tools or validate them, somebody who generally is working for an organization that is, essentially big tech and has many more zeros behind them than we do, is going to make these decisions for us, and we're going to be subject to their whims. To do this, we need to think kind of across the board. So we need to develop a new set of friends in both the House of Surgery as well as medicine at large. Similarly, we need to think up strategies and processes by which to compensate physicians for non-clinical work that's in this realm. And lastly, we need to think of new phenotypes by which to bring new lifeblood into the physician of the future. So obviously in a presentation for Grand Rounds, I would go over this a lot more, but these are the essential ideas. I'd be happy to take any questions.